Hi, I'm Jack Weeks with GPM Hydraulic Consulting, the nation's leader in fluid power training, troubleshooting, and reliability. Today we would like to talk about regenerative flow. A lot of people misunderstand regenerative flow because it just doesn't make sense to have pressure applied to both sides of the cylinder. Right? But here's how it works. Now this is a standard cylinder configuration. You see that we apply flow to the piston side, the cylinder extends, and oil in the rod side is directed back to tank. Right? But what happens if we put pressure on both sides of the cylinder? Now a lot of people would look at this and say, well, we're putting pressure on both sides, putting the same pressure on both sides. The cylinder will stand still. But in fact, let's look a little more closely. You see, we are definitely going to generate a force on the piston side to extend the cylinder, and we'll generate another force on the rod side to retract the cylinder. The force on the piston side will be greater. Why? Well, that is because we have a greater surface area on the piston side. The formula to figure this out would be force equals pressure times surface area. Right now we have less surface area on the rod side because the rod is taking up some of the space. Consequently, we're not going to generate as much force to retract the cylinder as we do to extend it. Assuming that the weight of the load is less than the difference between these two forces, the cylinder will in fact extend. Naturally, this only works with a light load or no load. But if our purpose is to get the cylinder extended rapidly into position, then regenerative flow is going to work. Right? So, which one moves faster? Well, the one with regenerative flow will move faster because when we apply flow to the piston side, the cylinder extends, but something has to happen to the oil in the rod side, doesn't it? All right, so the oil in the rod side is directed over here to the piston side, joining the flow that's coming into the piston side. So we have a greater flow rate on the bottom cylinder than we do on the top cylinder to extend it. The regenerative flow circuit will extend the cylinder more rapidly. Right now we have a problem with both of these cylinders, don't we? We can extend both of them. We can't retract either one. So typically they're going to be connected more like this, using a directional valve. And you see that our A port is connected to the piston side of the cylinder. The B port is plugged off. So when I energize the A solenoid, that will shift the directional valve into its A or straight arrows position. That will direct flow from the P port out of the A port into the piston side of the cylinder. Oil that comes out of the rod side is directed back to the pressure line where it comes back into the P port of the directional valve, joining the flow to the piston side, giving us a greater flow rate and extending the cylinder very rapidly. To retract the cylinder, we'll energize the B solenoid. That will shift the valve to its B or crossed arrows position. The B port is plugged off, so we're not applying any pressure to the piston side. We'll just drain oil out of the piston side through the A and the T ports, and the cylinder will retract. Now, if you found this tip helpful, visit our website at www.gpmhydraulic.com and learn about our two-part training process.